Okay, welcome to The Explainer. I'm absolutely thrilled you're here today because, wow, we are going to unpack a truly fascinating intersection of disciplines right now. We're diving straight into what actually happens when complex, hard physics totally collides with legal causation in a courtroom. Our source material today is a highly detailed scientific analysis of a very specific legal claim, and it uses the literal laws of statistical physics, thermodynamics, and fluid mechanics to test a theory of criminal liability. It's a wild ride, so let's just dive right into the deep end.
Right off the bat, I want you to ask yourself, could a single, solitary drop of warm water actually cause a tsunami? Intuitively and, well, scientifically, that is a completely ridiculous premise, right? But keeping that absurd, exaggerated image in your mind is absolutely crucial for this because it perfectly sets up the massive category error we are exploring today. We're going to look at how mixing up totally different scales of reality can lead to fundamentally flawed conclusions.
So the whole thing starts with this highly specific legal claim from our source documents. The prosecution basically argued that a defendant who is acting as a minor, isolated edge node, which really just means someone on the absolute outermost fringe of a social network, forwarded a single post that got practically zero engagement. Yet the legal claim here is that this specific, totally isolated forward directly caused a massive, systemic public order disruption. The sources we are breaking down today put this exact logic right under the microscope of hard science.
Which brings us to the core concept. Fluctuation is not phase transition.
To really test this, we need to pivot over to the core scientific framework of statistical physics. Physics actually gives us a rigorous mathematical vocabulary to test if a tiny, microscopic action can genuinely cause a massive macroscopic event. And it all boils down to two concepts: fluctuations and phase transitions. A fluctuation? Well, that's just your everyday background noise. It's the constant, random jiggling of molecules in the air in your room, or just the everyday chatter on a social network. It's totally normal. A phase transition, on the other hand, is a structural, systemic, macro-level change. Think of, an entire lake of water freezing into solid ice, or a massive societal disruption. Fluctuations happen by the billions every single second. Phase transitions are incredibly rare and require very, very specific conditions.
And honestly, this brilliantly illustrates the core conflict here. If we map the legal argument directly onto these physical terms, side A, the defendant's single-forwarded post, is the exact definition of a microscopic fluctuation. It's just a tiny blip. Side B, the resulting severe social disruption the prosecution is alleging, is a macroscopic phase transition. Now, the legal argument assumes that side A directly equaled side B. But as our scientific sources point out, physics strictly, unequivocally forbids drawing a straight, unbroken line between these two things without something else happening right in the middle.
That something else is the missing critical point.
Let's take a sort of Mythbusters approach here for a second and explain what the laws of physics actually require for a macro event to occur from a micro disturbance. For a phase transition to happen, you absolutely must follow these steps. Step 1. The entire system has to reach a critical point. It has to be highly sensitive, totally primed for change, kind of like water heated to exactly 99.9 degrees. Step 2, the correlation length must expand. That means local, disconnected parts of the system suddenly start syncing up across vast distances. Only then, at step 3, can a macro phase transition occur. The sources emphasized that the prosecution literally skipped steps 1 and 2. They blamed the tiny spark without ever proving the room was actually filled with gas.
In fact, the math proves the exact opposite. The source analysis shows that the defendant's actual influence was characterized by a branching ratio, or R0, which is much like the metric we use to measure viral spread in an epidemic, that was far, far less than 1. In network physics, if your R0 is less than 1, your signal just doesn't cascade. It dies out exponentially. It hits a wall. It is statistically near 0. The defendant was essentially operating in a topological dead zone, basically a dead end. So a systemic cascade starting from this exact node wasn't just, unlikely, it was physically impossible.
Let's look at a few examples of this in The Absurd Analogies.
To really hammer home just how massive this category error is, the source materials dive into what I like to call an analogy cascade. By applying the prosecution's exact legal logic to other established domains of physics, we can see just how absurd the premise becomes. If we apply this logic to thermodynamics, they're essentially arguing that the random movement of one single air molecule caused the temperature of an entire room to suddenly spike. In electrical circuits, it's like saying one stray electron's fluctuation completely crashed the entire national power grid. In astrophysics, it's claiming a literal grain of sand altered the gravitational structure of a whole galaxy. I mean, come on, you'd be laughed out of the observatory for sure. In every single scientific reality, these are firmly classified as impossible events.
Let's expand on this whole scale journey a bit more. Think about atmospheric physics. A human breathes out, right? That physically pushes air. It is technically a physical disturbance. But to claim that one person breathing out in one city directly caused a massive typhoon in the Pacific Ocean is a complete fundamental misrepresentation of scale. There is this vast, unbridgeable gap between the microscopic action and the macroscopic result.
And the cascade just continues across every hard science. In fluid mechanics, dropping a pebble into a totally isolated dead-end pool of water cannot, under any circumstances, create a tsunami in the main ocean. In solid mechanics, a sparrow landing on a bridge isn't going to suddenly cause the steel to melt. And in quantum mechanics, a single random quantum fluctuation definitely doesn't dictate macro-city traffic. Without a pre-existing highly sensitive, critical state, these microdisturbances are just instantly absorbed and completely dissipated by the system's everyday background noise.
Okay, moving on to severing the causal chain.
So let's pull all this rigorous scientific analysis back into the legal realm. How does physics objectively evaluate this specific criminal charge? Well, it evaluates it by testing the integrity of the causal chain. The sources impartially conclude that the laws of physics entirely sever the causal chain required for a legal conviction in this instance. Why? Because absolutely no critical parameter was ever proven to be reached by the system. There was zero measurable propagation path linking the defendant to the macro event. The causation was physically blocked by the node's topological isolation, meaning it was just entirely cut off from the broader system. So it's a fundamental category error, literally mistaking normal background noise for the root cause of a systemic failure.
Which perfectly brings us to this incredibly powerful summary derived right from the scientific models analyzing the case. A macro phase transition cannot be blamed on a micro fluctuation without a critical state. You can't blame the tiny pebble for the massive dam breaking if the dam was already crumbling under the weight of 1 million tons of water.
I really want to leave you with this final, provocative thought today. If modern physics tells us that complex systems fail because their overall structure has already reached a critical, highly unstable state, why on earth are we spending our time blaming the everyday background noise? It fundamentally challenges how we think about cause, effect, and ultimately justice itself. Thank you so much for joining me for this explainer. Keep questioning the scale of the things around you, and I will see you next time.